afternoon all. Today we are discussing about the microwave test bench experiment. Okay, today we have to find the frequency of the microwave signal. This is the test bench setup. This is a test bench setup where we see the microwave source. This is a microwave source and we have two connections from the microwave source. That is a gun supply which is connected to a gun diode and the pin supply to the pin modulator. Before starting the experiment, I will just explain each of the components of the microwave test bench. This is a switch, it's a gun diode, it's an isolator, pin modulator, attenuator, frequency meter, detector, sliding carriage. We have three connections here. A gun supply is connected to gun diode, pin supply is connected to pin modulator, and we have connected the CRO from the detector to the CRO to observe the output. First, we have to turn on the supply and ensure that you are not you increase the power supply and it should not go beyond 10 volts. Maximum volts should be 10 volts or less than 10 volts. And I have connected the gun supply to the gun diode. So it generates an oscillation and we are supposed to measure the frequency of that oscillation. And the other connection is from the pin supply which is connected to the pin modulator. This pin modulator modulates the incoming signal. That is, it actually do the amplitude modulation. Why the modulation is done is because it is difficult to measure the frequency of a gigahertz signal on the CRO. So it is being modulated and the modulation technique used is an amplitude modulation. Then we have an attenuator. By varying the attenuator, we can vary the power or voltage on the CRO. You can just observe the CRO. I am just varying the attenuator. You can see the increase in voltage by when you are moving up. As the attenuator is moving up, as I am rotating the attenuator, you can see increase in the amplitude, increase in the voltage, and if I turn back the attenuator, you can see the decrease in the amplitude. So we have to measure the power with attenuation, without attenuation. What exactly happens here is when I turn the attenuator, as it go upwards, the signal is not blocked. The signal which is passing through a waveguide. So this is a waveguide. This is a waveguide. The signal which is passing through this waveguide is not blocked, and so you can see the maximum amplitude and you can measure the maximum power from power. As you turn the attenuator, as it moves down, it blocks the signal. So you can see, you can observe on the CRO decrease in the amplitude, decrease in the voltage, or you can measure the amplitude, power. You can measure the power. Next is, this is a frequency meter and this is a sliding carriage. I told that we are measuring the frequency of the oscillation. So there are two methods, two ways to measure the frequency of oscillation. One is a direct method, that is using a frequency meter. The other one is an indirect method using a sliding carriage. Okay, so now this is a frequency meter which is made up of an LC component. But as I turn this frequency meter, at one particular point you can see the dip in the amplitude. We can see the dip in the amplitude which is being seen, which we are seeing on the CRO. At that particular frequency, that is the frequency of resonance, and we have to measure that frequency, and that is the frequency of the microwave signal. That is the frequency of the oscillation generated. Fine. So I'll just make it 0. I'll just turn the frequency meter and make it 0, and I slowly rotate. Now I'm slowly rotating the frequency meter, and you keep on observing the CRO. Keep on observing the CRO as I turn, as I move on, as I turn, at one particular frequency you can see the dip in the output, a dip in the signal. That is a resonant frequency, and that is the frequency of the microwave signal. See, you observe the dip. See, at this particular point you observe the dip, and that frequency is a resonant frequency, and you have to measure that frequency, and this is how you measure the frequency. See, this is a frequency meter. You are just observing the two horizontal line, red color line, and one red color line vertical. So where exactly the red vertical line is coinciding between the two horizontal red line, that is the frequency of the oscillation. So here it is almost 10 point, I think it's around 10.4 is that, this is around 10. Around 10 is the frequency of the oscillation, frequency of the microwave signal. This is the This is the indirect way of measuring the frequency of the signal. That is, you have to move the sliding carriage. So the sliding carriage is on one particular point. Okay, I'll just, from this point I'll move the sliding carriage. You have to measure the two successive maxima or two successive minima. So this is one point, and as you move the sliding carriage, you can see that you are moving the sliding carriage. You got the minimum value at one, you get the minimum value at one particular point. So this is a minimum value, and you have to measure this minimum, or you can measure two successive maxima or two successive minima. So you got it is been decreasing, and next maxima, where exactly you get the next maxima, you have to measure that. So this is first maxima, and this is next maxima. So you have to measure using a relation MSR plus CVD into LC. MSR plus CVD into LC. Main scale reading, coinciding vernier scale reading, and the least count. Least count is 0.01. Okay, this is a relation to measure the frequency of oscillation. So here 1 by lambda naught, where lambda naught is a free space wavelength. 1 by lambda c. Lambda c is a wavelength, waveguide cutoff wavelength, and you have a lambda g guided wavelength. And here, and we are taking a lambda c equals to a, where a is the dimension of the waveguide. So this is a. We have to measure this a. This is around, you get around you have to use, using a scale, you have to measure this dimension, and you have to use relation. You have to use this relation, that is MSR main scale reading and CVD 4, and you have to use this formula. You have to use this formula to find out the value, that is D1 equals 10.94, and you have to find next maxima. This is for one maxima, this is for the next maxima, and using a relation you will find out the so we are using this relation. We have to find the frequency of the oscillation. First we have to find lambda g equals to into difference of D1 and D2. So what is D1 and D2? We are measuring the D1 and D2, that is distance between difference between two maximum or two minimum. So we have considered here difference between two maximum. To find out D1, this is a relation, main scale reading plus CVD into least count, and the least count is 0.01. Similarly, D2 is found using the same relation, and lambda g is found using the relation 2 into D1 minus D2, and you get some value. You get lambda g equals, we can calculate that. You get some value lambda g, and you can substitute the value of lambda g here. This is a main relation to find out the frequency of oscillation. You can substitute the value of lambda g here, and what is lambda c? Lambda c is 2 into a. Lambda c is 2 into a, where a is the, as I told, it is the dimension of the waveguide, and it is around 2.3 centimeters. So lambda c is 2 into 2.3 centimeter. The value of that is substituted here, and you have to find 1 by lambda naught square. After finding 1 by lambda naught square, you can find out the frequency of the oscillation. F equals c by lambda naught. We know the value of lambda naught, and we know what is the value of c, and you can find the value of frequency of the oscillation. So this is how you calculate the frequency of the oscillation, and you, as I told, you have two methods to find the frequency of the oscillation. One is the direct method, that is using a frequency meter, and the other one is the indirect method using the sliding carriage and the formula. And one thing you have to make sure that both the methods you have to get the same frequency, almost same frequency, same value you have to get. And also we will be finding the VSWR, voltage wave standing ratio, and the relation to that is given by root of E max by E minimum. You have to turn the sliding carriage. At one particular point you have to turn the sliding carriage, and at one particular point you get the maximum value. That maximum voltage you have to note it down, and again you turn the sliding carriage and you get a minimum value at one particular point. Minimum value, that is minimum voltage you have to note down, and you can find the VSWR. You have to conduct this experiment for both match load and the unmatched load. So we are connecting a match load here. We can take out this component. This is a match load, And you have an unmatched load here. This is an unmatched load. You have to fix it like this, and with unmatched load the same procedure is done to find out the frequency with the matched load and the unmatched load. So we got to know how to calculate the frequency of the oscillation, how to calculate the VSWR with respect to both matched load and the unmatched load. We can also calculate the attenuation with attenuation and without attenuation. As you turn on the attenuator, as it goes up, you can see increase in the amplitude, that is you can calculate the voltage, and when you turn the attenuator towards downwards, you can see the signal will be blocked, so you can see the decrease in the amplitude.